Electrical engineering interview questions and answers. In this video, we will show the frequently asked electrical engineering interview questions and answers related to electrical engineering. 1. What is electrical engineering?
Electrical engineering is the field of engineering that generally deals with the study and application of electricity, electronics, and electromagnetism. Electrical engineering deals with high voltage, especially AC, above the range of 110 or 220 V. Moreover, electrical components and devices use alternating current, AC/voltages, and tend to be larger in size and require 230 V in UK and 110 V in US single-phase AC voltages, whereas in industries and power stations, it may be up to 11 kV, and for transmission, it may be higher than 400 kV.
2. Why transformer rated in kVA, not in kW?
When manufacturers design a transformer, they have no idea which kind of load will be connected to the transformer. The load may be resistive, inductive, capacitive, or mixed load, resistive, inductive, and capacitive. It means there would be different power factor at the secondary load side. The output of real power may vary depending on the power factor. Thus the manufacturer denotes it as: this transformer can provide X number of amperes at Y amount of voltage. This way, they go for voltage amperes, as in, voltage multiply amperes, instead of watt in case of the rating of a transformer.
3. What is an ideal transformer?
An ideal transformer is an imaginary transformer in which no losses occur at all. In other words, the transformer input power is equal to the output power of the transformer. They have 100% efficiency. It is just a theoretical transformer because there must be some losses in a real transformer. Transformer input power equals transformer output power.
4. What are transformer losses and their types?
A real transformer has the following losses. Copper losses, winding resistance. The losses occur due to the current flow through the windings that causes resistive heating of the conductors. Core or iron losses. There are two types of core or iron losses. 1. Hysteresis losses. These losses occur due to the magnetic field reversal. The magnetization and demagnetization of the core consumes some energy, also known as hysteresis loss. 2. Eddy current losses. The losses due to the current generated inside the core. The eddy current causes the resistive heating of the core. Various other losses include stray losses, leakage flux, dielectric loss, other losses, magnetostriction losses, mechanical losses.
5. What is transformer efficiency and all-day efficiency? What is the condition for maximum efficiency?
Transformer efficiency. The efficiency of the transformer is given by the output power divided by the input power. Some of the input power is wasted in internal losses of the transformer. Efficiency equals output power divided input power. All-day efficiency. The ratio of energy delivered in kilowatt-hour to the energy input in kilowatt-hour of the transformer for 24 hours is called all-day efficiency. All-day efficiency equals output in kilowatt-hour divided input in kilowatt-hour. Condition for maximum efficiency. The copper loss must be equal to the iron loss, which is the combination of hysteresis loss and eddy current loss.
6. What is the voltage regulation of the transformer and why is it important?
The voltage regulation of a transformer is the percentage change in the secondary voltage from no load to full load condition. Ideally, the secondary voltage remains the same throughout the load, in which case the voltage regulation is 0. But practically it varies with the power factor of the load. The voltage regulation value provides the efficiency of the transformer, and it is best to prefer a transformer with low voltage regulation.
7. Why the current transformer's secondary should not be open when there is current flow in its primary.
The current transformer is essentially a step-up transformer that increases the voltage and decreases the current on the secondary side. Under the open secondary condition, the primary current becomes the magnetizing current that generates a very high secondary voltage that can damage the insulation as well as can pose danger to personnel.
8. How do you know if a circuit is inductive or capacitive or purely resistive?
The total impedance of the circuit can be used to identify the circuit. If the imaginary part of the total impedance is positive, then it is an inductive circuit. If the imaginary part is negative, and then it is a capacitive circuit. If it is 0, then the circuit is purely resistive.
9. Does current lead or lag the voltage in an inductive or capacitive circuit?
The current lags the voltage in an inductive circuit, while the current leads the voltage in a capacitive circuit.
10. What is a unilateral and bilateral circuit?
A unilateral is a type of circuit whose properties change with the direction of current flow or the voltage. The properties of a bilateral circuit do not change with changing the current direction or supply voltage.
11. What is a linear and nonlinear circuit?
In a linear circuit, the relation between the current and voltage is linear, directly proportional. The circuit parameters such as frequency, resistance, inductance, capacitance, remains constant with varying current and voltage. While in the nonlinear circuit, the current and voltage does not have a linear relationship. The electrical parameters of such circuits changes with varying voltage and current.
12. What are the limitations of Ohm's law?
Ohm's law does not apply to a unilateral circuit or a nonlinear circuit. The criterion for Ohm's law is that the resistance must be constant, which also depends on the temperature. Whereas, the resistance of a nonlinear or unilateral circuit varies with voltage and current. Thus it is not applicable in such a circuit. Also, the temperature must remain constant.
13. What is the maximum power transfer theorem?
It mentions the condition for maximum power transfer from source to load. It states that in a linear, bilateral network, the maximum power will be transferred from the source to the load when the external load resistance equals the internal resistance of the source or Thevenin's resistance of the circuit.
14. What is active, reactive, apparent, and complex power?
Active power. It is the actual power that is delivered to the load, such as transformer, induction motors, generators, and dissipated in the circuit. It is denoted by P and its unit is watts. Reactive power. The powers that continuously bounce back and forth between source and load is known as reactive power. It is denoted by Q and its unit is voltage ampere reactive. Apparent power. It is the product of voltage and current without referencing the phase difference between them. It is a combination of active power and reactive power. It is denoted by S and its unit volt-ampere. Complex power. It is the product of voltage and current concerning the phase difference between them. It is the complex sum or vector sum of the active power and reactive power. It is denoted by S and measure in voltage ampere reactive.
15. What is a leading and lagging power factor and how can you improve it? State the methods of power factor correction.
The cosine of the angle between voltage and current is called the power factor. If the current leads the voltage, it causes a leading power factor. If the current lags voltage, the power factor is lagging. Most loads are inductive, that causes a lagging power factor. Thus these following methods are used for power factor correction to nullify the lagging current. Static capacitor. The capacitor helps in providing a leading current that eliminates the lagging component of current and improves the power factor. Synchronous condenser. It is an overexcited synchronous motor with no load that also provides a leading power factor. Phase advancer. Phase advancer is a simple AC exciter that is connected to the main shaft of the motor and operates with the motor's rotor circuit for power factor improvement. Phase advancer is used to improve the power factor of induction motor in industries.
16. Why do we improve the power factor?
The reason for improving the power factors are stated below. Large line losses, copper losses. Line losses depend on current. The low power factor draws a large amount of current as compared to the high power factor. The large kilovolt-ampere rating and size of electrical equipment. Power factor is inversely proportional to kilovolt-ampere. Low power factor equipment with a high kilovolt-ampere rating is larger in size. Large conductor size and cost. We need large conductors to transmit the heavy current required due to the low power factor. Poor voltage regulation and large voltage drop. The large current due to the low power factor causes a high voltage drop that needs to be regulated more often than usual. Low efficiency. The losses due to the high current flow and voltage drop deteriorate the efficiency of the system. The efficiency is maximum at power factor equals 1.
17. Why did the motor rate in kilowatt instead of kilovolt-ampere?
As we know, the transformer is rated in kilovolt-ampere because its power factor depends on the nature of the loads. However, motor has a fixed power factor, motor has defined power factor, and the rating has been mentioned in kilowatt or horsepower on motor. In more clear words, the motor only consumes active power and provides mechanical power in horsepower or kilowatt at the motor shaft, and that is the reason for a motor rating in watts.
18. What is a motor starter?
Motor starter is a device that connects in series with the motor to decrease the starting current that could damage the windings in normal conditions and gradually increase current after starting the motor, in other words, start or stop the motor, and provide overload protection.
19. What is a magnetic starter?
A magnetic starter is a device designed to provide a safe starting method to electric motors with a heavy load. It includes a contactor as an essential component, while also providing power cutoff, undervoltage, and overload protection.
20. Why is battery rating in ampere-hour and not in volt-ampere or watts?
A battery converts chemical energy into electrical energy, which is the charge stored inside the chemicals. The amount of current it can supply for a said time, thus ampere-hour, is the unit for its rating. While the batteries supply direct current which has no phase or frequency, thus there is no concept of power factor or reactive power, thus no need for expressing it in volt-ampere, and it's rated in ampere-hour.
21. What is a primary and secondary cell?
The primary cell is a non-rechargeable battery that cannot be recharged by any means. They are disposable and cannot be used once they are fully discharged. They are mostly used in toys, handheld devices, and remote controllers. The secondary cell is a rechargeable battery that can be recharged several hundreds of times, depends on its life cycle. Their initial cost is expensive compared to the primary cell. They are mostly used in cell phones, vehicles, generators.
21. What is the difference between circuit breaker and isolator?
Circuit breaker. A circuit breaker is a protective electromechanical device used to control the flow of current, same as a fuse. It automatically breaks the circuit in case of fault conditions like short circuits and overload. It can also manually break the circuit. It is on-load and off-load device. It means it operates in both on or off supply condition. Isolator. An isolator is a mechanical switch used for isolating or disconnecting power supply in substations. It is an off-load device. It is operated when the power supply is off.
22. What is the difference between miniature circuit breaker and molded case circuit breaker?
The MCB stands for miniature circuit breaker, and it is used for current ratings lower than 100 amperes with interrupting ratings of below 18 k amperes. Its tripping characteristics cannot be adjusted and they are used for domestic purposes. The MCCB stands off molded case circuit breaker. It has a high current rating of around 2500 amperes, where its interrupting ratings are between 10K to 200K amperes. Also, its tripping characteristics can be adjusted. They are used in industries.
23. What is the difference between a generator and an alternator?
A generator and an alternator both convert the mechanical energy into electrical energy. The key difference between them is that the generator has a stationary magnetic field. The armature rotates inside a fixed magnetic field. While in an alternator, the magnetic field rotates inside a conductor winding's stator. So the stationary part of the alternator is the phase conductors.
24. Define the term capacitance and inductance.
Capacitance. Capacitance is the ability of a component to store charge between two plates when there is a potential difference applied. It is denoted by C and it is measured in farads. Inductance. Inductance is the ability of a conductor to resist or oppose any change in the current. The current generates a magnetic field whose strength varies with the current. It is denoted by L and is measured in Henry.
25. What are the different colors on wires indicate?
The different colors of the wires are used for phase indication purposes. They represent different phases, the neutral and earth cable. The color code may differ around the world, but usually, the earth wire remains the same green with yellow stripes.
26. How do you decide what size of electrical wire do you need?
The proper size of the wire mainly depends on the amount of load current and voltage supplied as well as the length of the cable. Usually, the voltage drop in cables should not be greater than 2.5% of the supply. Measure the supply voltage. Calculate its 2.5% allowable voltage drop. Measure the required length of the cable in meters. Divide the allowable voltage drop with the length. The resultant is the max allowable voltage drop per meter, and your required cable size should have a lower voltage drop than this. Calculate your load current. The cable charts provide this info such as voltage drop per meter, current capacity, cable size, etc. Match your calculation with the chart and find your required cable size.
27. What are the types of semiconductors?
The main two types of semiconductors are: intrinsic semiconductor, the semiconductor that has the same number of electrons and holes. They exist in their natural form. Extrinsic semiconductor. These semiconductors have foreign impurity, electrons or holes, inserted artificially through the process called doping. The impurities are intentionally added to change its electrical properties. N-type. The dopant in this type of semiconductor increases the number of free electrons. So the majority carriers are electrons in N-type. P-type. The dopant of such semiconductors adds in the excess number of holes. The majority of carriers in P-type semiconductors in holes.
28. What is a transistor composed of?
Transistor is made of different combinations of P-type and N-type semiconductors. The doping in combination and different shapes of semiconductors form different types of transistors with different electrical properties.
(29) What is the role of a transistor in a circuit?
Mainly the transistor can be used for two reasons. Switching. To switch on or off the flow of current in a circuit. The switching depends on the input voltage or current. Amplification. To increase or amplify the input signal that has very low power into a high power signal.
30. What will be current if the total resistance in a series circuit doubles?
The current has a linear inverse relation with the resistance. Thus, doubling the resistance will decrease the current by half.